All right, everything works. This is off to a great start. All right, so first I just want to say thank you so much to Carvana for this great venue. It's always really fun to come to a meetup here. They do a great job hosting, and thank you, Zach, for making this just such a good place to speak at and a good place to build community. So the title of today's talk is Real-Time Web Applications with WebSockets and Hooks. So give you a little bit of background. I've been working with kind of a heavy real-time application for the last 5 to 6 months. And I had some experience with WebSockets before I came in. And honestly, I've learned so much since then and broke down like a ton of walls. And now that hooks are out, I see how easy it can be. So I'm going to tell you a story today about what it's been like to use WebSockets in this application that we're building, and how I see hooks kind of like helping to evolve over time. So really quick, I am an engineering manager at Formidable. We are a software consultancy. We work a lot with Fortune 100 companies kind of across the nation and across the world. We help them level up their teams, scale code bases. Lately, we've been doing a lot of performance auditing. So we're kind of like in the nitty gritty, like helping existing teams further along their development practices. And I mean, right now we're hiring some Node and React engineers. If you all want to talk to me afterwards, we're always kind of like looking to grow. So, okay, all right. So the challenge that I started off with. Client wanted to build this UI that basically relied on 6 different like entities that updated in real time. We're talking like real quick 300 millisecond like intervals. There's a lot of componentry, a lot of DOM elements being processed here. So this was kind of a challenging thing for me to like wrap my head around of like, how do we take this much data and throttle it into a UI? And it works on my fully loaded MacBook Pro, but probably not on some people's computers. So we need to maintain performance along the way. How can we do that? And also, I've worked with WebSockets before. They're unique. You can have all sorts of communication protocols going across the wire. Some are well documented. I think there's like Google Stomp and obviously like Socket.io if you have a Node backend. But in general, like WebSockets are kind of the Wild West when you're working on a team that is trying to decide on a protocol. So yeah, there was a lot to like kind of grapple here with how do we want to, one, receive data? Do we receive it all in one payload? Do we receive just like, a snapshot and then updates on top of that? And how's that going to scale down into the web application? The most critical thing here is the user experience. So we're trying to keep that in our minds. So this is an idea of the UI. It's a little bit more beautiful than this in production. This is just kind of showing you, we have these components that each hook into specific WebSocket connections. You're going to get different entities, different data types coming across for each of these components. So this is a static example. I warn you, this might be epilepsy inducing. This is a little flashy. So this is what could really happen in real life, is you get all these data updates coming into the components, and this is what your updating cycle could look like. I'll actually show you. So like, this might be one user session, and then if you come back again, it's slightly different. And so how do we build a UI that can respond to data that's coming in at say 100 milliseconds per second or 600 milliseconds per second? The kind of threshold that we settled on was 300 milliseconds is pretty much what a user can perceive. So there's no reason for data to be coming in faster than that and our React code to be updating. So in our minds, we're building an MVP. We're working really quickly. And we just need something to kind of throttle that down. So this is where we landed. We decided that, hey, we're going to have 6 separate WebSocket connections. Those will update a singular store. And that singular store was essentially an RxJS observable. Has anybody in here worked with RxJS by chance? It was kind of new for me. It was already kind of existing in the code base, and we have some developers who prefer reactive coding. And so yeah, it was the perfect solution for this problem, where an observable is essentially a store that we can push data to And then we have like this other chain function called scan that allows you to essentially like read from that store whenever you decide. So we set a throttle in there that basically would throttle it for 300 milliseconds. And then we'd get that data, and then we'd call a singular set state. So this might be a better diagram here. So as you can see, we have like, this is only 3, but like imagine 6 or 7 or 8 WebSocket connections going into an RxJS subject, and that would make its way down into a React provider that is then calling set state and passing that state to all their children. This is probably the hardest way about going about things, but it's what we settled on. And you know, it's working. It's in production, and there's users using it. But the bottlenecks here are that single set state right there receives so many updates all at once, because you're saying, hey, every 300 milliseconds, we're going to recall set state on you. Even if the underlying data, say instrument data, doesn't give you new data back for, you know, 1 second, 2 second, 3 second, we're still going to update that set state call and then propagate that into children. So what that does is now you have these children who want to update. So we have to have should component updates everywhere. And it's, you know, it just hasn't scaled super well. This is where we ended up landing. You know, I showed you that diagram earlier of everything updating independently. We ended up landing at this single 300 millisecond, you know, upload or excuse me, update render tree. So lessons learned, it requires all the sockets to be opened all at once, because we have that one single store. Doesn't scale super well. And now we have hooks. So like, let's use hooks. Who's used hooks? Sweet. Who's used them in production? Hell yeah. So use it in production. It's there today. It's super stable, quote unquote. Yes, it is. We're using it today, and honestly, the tooling is great, and the kind of developer gains we've seen are kind of unbelievable. So what are hooks? Hooks basically let you use state and other React features without having to write a class. So everything is a function. You have, you know, your stateless functional components, and your React classes are kind of the 2 ways that people write things. With hooks, everything can just be a single function. And with hooks, React team is actually providing opinions now about managing state. Traditionally, React has always been kind of agnostic of, hey, we'll help you with everything, but it stops at this one layer where you should reach for Redux maybe, or, you know, other tools. And we're at this stage now where they've given us context. Context has always existed, but it's first class now. They've given us context, they've given us hooks, they've given us all these tools that we can now leverage to create our own state store library. And yeah, so hooks are extensible, they're functional, and they're gonna blow your mind because you can just use them. They're highly reusable, and it's super great. So if I can move my cursor over here. So this is an example of a hook. This is a really simple example. So if you've ever had to, say, draw inline styles with a hover, and you don't want to use CSS for whatever product requirement reason. So this is the idea of maybe in your code base, you have this code where sometimes you want to have a component that receives a hover. This is one hook that can be shared. And basically what it does is so walk you through it here. We have this use state hook here. This use state hook has a default state of false. So rather than set state, where that's essentially one store that you would then update with keys, use state would be for one single entity. So use state for this value is false. We have a use ref hook. If you look at the use ref docs, it kind of shows you how to implement it. It's yeah, it basically allows hooks to reference the React refs. And then, so I'll talk a little bit about the biggest gain here is the life cycles that you get with the use effect. So think of this as componented mount, where you would sometimes do all of your, you do like your side effects of, I want to add this event listener, or I want to interact with some thing in the window. And then on component did unmount, you would then tear down those side effects. And you would have to do this in all of your class methods. So if you had three components that you all wanted to have this hover state working in, you'd have to add these in different components or have a higher order component or something. But hooks let you create this kind of like one reusable function that you can then bring in and say, cool, give me a ref to your component, and I'll tell you if it's hovered or not. And you can just pass this around in any of your stateless functional components. So yeah, super reusable. So I'm going to show you two demos that are two things that I've built in this demo that I think are pretty rad. If I can change the Zoom link here. 1 second. I'm just going to do my whole screen, so hope that works. Cool. All right, so I built this tool here to basically allow me to choose different currencies and imagine that you're seeing their price update in real time. So what's happening every time that I select a currency here is we are going and we are creating this WebSocket connection over here. And then when we unsubscribe from this, the WebSocket connection is going dead. And essentially we're being good neighbors by saying, kill this WebSocket connection. So in the code here, I'll kind of show you the actual bits that we did to build this dropdown. Is we're using a use state hook. This use state hook has a default property of kind of just an empty array. And by default, it's returning these, it's giving me currencies, which is the value, and then it's giving me an updater method. So this updater method, what you can think of it as is a set state, but for this singular entity here. And you can use it just like set state, where you could either use it as a, hey, this is going to be the new value. So that would be like an atomic update there. Or if you want to build on the, say, currencies value here, you have this callback function. And this callback function gives you access to the current value and then lets you modify that. So this replaces all the class logic that you would typically have with, hey, here's my state, here's a handler, and call set state. All of that is just done by this, which is super rad. So just that kind of shows you how I built this simple UI here. But the really fun part is this subscription. So in this subscription, you can see I have this use WebSocket hook. What was that? Oh, definitely. My bad. Cool. All right, so this use WebSocket hook, I'm basically just passing in a URL and saying, make this connection. And then it's giving me back the data as well as just a flag that says it's actually open, because WebSockets can take some time to instantiate. So inside of this use WebSocket hook, we're doing some pretty cool stuff. We have so we have an effect that is essentially containing all of the WebSocket logic in here. We're opening up a new WebSocket with the URL, and then we're attaching these events to it. So on open, we're going to do a thing, and then on message, we're going to do a thing. So what is this doing a thing? You see dispatch in here. We don't have Redux, so what is this? Hooks have this new property called use reducer. So when you think about Redux, you have a reducer. And it's very similar to that in the sense of you can pass in a reducer with, say, like a switch statement here. And this is where you can modify some state and then return the new computed value. I created this other hook called use mutable reducer. I didn't create this actually. My former coworker, Brandon, shared this idea on Twitter, and it's really rad because it extends the use reducer and it allows you to use Emmer. Has anybody used Emmer here before by chance? Emmer is pretty rad. It allows you to create really atomic updates by mutating the current state, and it returns an immutable state. So what that does is basically lets us have either a use reducer hook that we can call directly with a normal reducer, or in this case, we turned it into a use mutable reducer. So like what's really cool about the hooks is you can extend them. So they give you these base things to work with use reducer, use context. You can just pull in a reference to a context provider and you can access it. So with hooks, you can essentially just come up with these infinite recipes of nesting, which is pretty rad. So I'll go back to this use context idea here, and we can talk about use effect, which is probably my favorite hook. So this comes directly from React. You see import use effect from React here. And this is my favorite hook because it's got this really awesome lifecycle method where it's only called on initial render. This is only called on initial render here. This return is essentially where you do all your teardown, and it's not called until either the component unmounts or this value changes here. So think of this as like the component update, updated, and if URL changes, I want to return this, tear it down, and then I want to reinstantiate this effect. So what this does is it allows us to, by default, if a new property comes in here and it's different, it's not going to redispatch the effect until, until this property is different. So this would essentially be the component did mount, I would say. You would think of this as component did unmount, and then you would think of this as component did update. Go ahead and call all this again. So this return never actually returns until the component is either unmounted or this changes. And you can, by default, just have it be empty to say we don't care about subscribing to any changes of value. Just let it exist in the nether. And yeah, so what's cool here is we're using two hooks. We're using the mutable reducer. We have this store property, which we're returning. That's the value of that reducer store. Think of it as like the state. And then we have this dispatch function, which is then tied into a reducer the same way that like Redux would be. So this dispatch function is great because it's being returned from this hook, and then we're using it inside of this other hook. So imagine a world where you could have 5 or 6 or 7 hooks in here, and they're all kind of using values and updaters from each other. It's really super powerful, and I guess I see it as we have a lot of tools that we can now use to make these really simple methods. Look, like this is opening up a WebSocket and setting some state. This is super simple. And that wouldn't have been possible, I feel like, before. It would have taken a lot more code and a lot more overhead. Yeah, we just have a really cool updating cycle. So anyway, that's kind of my talk. And I'd love to open up for questions because there's, a lot to cover here. But yeah, I hope you're hooked. Does anybody have any questions? Anybody want to talk hooks? Question. What's your favorite hook? I like the use effect hook and the use context hook. Use context is super cool because imagine, so you have your provider context, and ways that you'd normally access that consumer would be through like a higher order component, or there's kind of other ways, but this use context hook, you can basically just import consumer from wherever file you have this kind of context at. And now all of a sudden you can access and write to your context from within a hook. So imagine this WebSocket one that I just showed you. This is kind of a scenario that we're working through where we have 5 or 6 or 7 of these individual use WebSocket hooks opening up. I showed you what it looks like today with a single reducer. So each of these WebSocket connections today have a single reducer that they write to. Rather than writing to a single reducer, what if we just said, hey, use context store, and now we just write to that store. Now your WebSockets can open up. Maybe you want to hash the query so that way it's writing to a unique value. And if a WebSocket is open and another component tries to open up that same WebSocket, check to see in the provider or in the context if it's already open, and then short circuit and just read from that essentially. So there's all sorts of ways that you can then like pass state inside and outside of hooks via context. So it provides a nice escape hatch in some ways.
I guess I'm curious because you're saying you broke down a lot of walls and you learned a lot about services. What was your first step when you were like this is my problem. How do I solve it? Like, what was your first? Did you go to external sources? Did you browse Twitter? Like, comment said, like, what was the?
Yeah. So the first thing where WebSockets were like, what is this? Working with a team who has brilliant engineers, but we're working with a homegrown WebSocket protocol. And I've really only done much with like Socket.io, or I've done a little bit of work with you know, the messaging that is well documented, essentially, some sort of framework. So working with a homegrown WebSocket framework that had all these different steps, there's a lot of handshakes involved in WebSockets. You say, hey, I want to open up a connection. The WebSocket might come back and say, cool, that's great. Tell me about that connection. And then you go back and say, well, I want this. And then it comes back and says, all right, here's a snapshot. And then it gives you these stages along the way and says, okay, you're subscribed now. Here's a new payload. So figuring out that messaging was really hard, and figuring out kind of the right way, because they were asking me like, hey, how should we do this? So I went and looked at like some of my favorite WebSocket. The fact that I have favorite WebSocket connections, like that says a lot about me. So yeah, I'm a huge nerd and I like looking at documentation. So looking at like how Socket.io kind of does some of their messaging, or looking at like well-known protocols. So there's one like WS node that it's built on some sort of like well-known like documentation. But yeah, basically like I wanted to see how do other people do this, and not to say that they're right, but at least have something to talk about and like compare options. So yeah, trying to build on like previous work, I think, is something that can happen. This is actually pretty cool. I'm gonna put this code up online so you guys can all look at it, and I have a stupid little node backend that's just sending me data. So definitely like take a look, and you can see kind of like how some of these hooks are pretty powerful. But I'll share the link with somebody somewhere, and it'll end up in something. So yeah.
So how would you handle like disconnected from the server and reconnect?
That's the other thing about WebSockets. Side tangent, if you go in and you look at like how Socket.io handles like their framework, there's a lot of code there because they do a lot of stuff. This is why it's nice to own both the server and the client with Socket.io. Because if your WebSocket starts to fail, it falls back to rest. So that's a lot of code to build. With our practice in WebSockets, we did a heartbeat mechanism that kind of keeps it back and forth and open. In this case, in this like kind of hook here, Zoom's blocking me. In this hook, you know, it provides like on air is something that you can like tune into. You could probably do something like, say you had like a error state and then update, and then you said use state, and then say the error state is just false or something. You know, you could say on air, hey, trigger like update error state to be true. And then what that would do is then do this, and then you could say, hey, if error state changes, then rerun this hook and try to reestablish a connection. Like, I don't know, that's not much code to like do that stuff. That's the thing, is like once you start to grapple with, especially this guy down here, it's kind of crazy just how, I don't know, smart it is about the component lifecycle. And just the fact that this obeys like the component lifecycle and the renderings. When useEffect is called, when this hook is called, and then say it tears down or returns, I believe that actually triggers like a re-render, like on the first time. I'd have to look into exactly like how the re-renders work, but it's modifying the like component itself. So hooks are interacting with the component, and they obey the lifecycle hooks, and they also influence them too. It'd be a little weird. But yeah, that's a quick way that I would do that. Anything else? If you guys want to chat, if you all want to chat with me after this about hooks or things, come find me. And yeah, hope you learned something. Cool.